8.1 is all about adding and subtracting polynomials and learning how to name them. So let's talk about a couple of different things. We have monomials, which an example would be a real number, a variable, or a product of a real number and one or more variables. So here, this is a monomial. It's a real number. Here's just a variable, also a monomial. And then the other ones are products of real numbers and one or more variable. So those are all examples of monomials. And you can combine monomials to create larger expressions called polynomials. Now let's talk about ways that we name them. The degree of a monomial is the sum of the exponents on its variable. So the degree is the sum of the exponents on its variable. And we're talking about a monomial here. Constants have a degree of 0. And then we'll talk about the degrees of polynomials later, but let's look at the degrees of these monomials. So here's my exponents, here's my variable, 5x, and x is raised to the first power because it's just an x. So this would be a first degree polynomial. And here we have a monomial with a couple of different exponents. So it says the degree of the monomial is the sum of the exponents of its variables. So we would add 3 plus 2. So this would be a 5th degree monomial. Here, this is just 4. That's a constant, so it's a 0 degree. And here, some of the exponents again, we have x to the third, and y is just raised to the 1 because there is no exponent there, just like x is 1x. So 3 plus 1 is 4, so this would be a 4th degree monomial. So we can add or subtract monomials. It's just like combining like terms. What's the sum or difference in this case? And you see we have variables raised to the exponent of 2. So they are like terms, so we can combine them. We have 3x squareds, and then we're going to take away 5x squareds. So we are minus 2x squared. Again, we're kind of just gathering like terms. So here are our terms the same. It doesn't matter what the coefficient is, but we have x to the third y, x to the third y. So we have some terms we can combine. Negative, this would of course be a negative 1 x to the third y plus 4. So negative 1 plus 4 is 3x to the third y. Standard form, when we put things in standard form, we have to start with the biggest exponent and work our way down. It says degrees decreased from the left to the right. The degree of the polynomial is the degree of the monomial with the greatest exponents. So in this example, it's already in standard form. This is a 4th degree polynomial because that's the degree of the monomial with the greatest exponent. So if we're talking about the number 6, in this case, it would be a 0 degree, right? Because it's a constant. Number of terms, 1. If we're going to name it using number of terms, it's a monomial. Here we have 5x plus 9. So addition and subtraction separate the terms. So, but it's a 1st degree because it has just x to the 1st. It's linear, meaning we could graph this, it would be a line if it was y equals 5x plus 9. And number of terms, 2. Named using number of terms, it's a like a bicycle, binomial. Bicycles have 2 wheels, binomials have 2 terms. 4x squared plus 7x plus 3, again, we name it by the largest exponent, so x to the second, so it's a 2nd degree, and it's called a quadratic. And number of terms in this case, we have 3. So again, let's talk about bicycles. If we have 3 wheels on it, it's a tricycle. So it's a trinomial. 2x to the third. This is a third degree because it has x to the third. It's cubic. If it's to the third, it's cubic. And how many terms in this case? It's just the one term. So again, it's just a monomial. Here we have 8x to the fourth minus 2x to the third plus 3x. So we look at the degree on the largest exponent. This is the fourth. So fourth degree. And it's just called a fourth degree polynomial. And in this case, we have 3 terms. So it's called, again, a trinomial. So let's classify them. First, we have to get it in standard form or check to see if it's in standard form. Again, we want to start with the highest exponent. So the standard form, we'd need to rearrange. So this is a positive 4x squared and then a positive 3x, so plus 3x. I'm just flip-flopping them. Degree, second degree. Leading coefficient. What's the number in front? It's a 4. And how many terms does it have? 2 terms. And the type. So this type, it's 4x squared. So this is going to be a quadratic. And here, classifying polynomials, again, standard form, we have to look for the largest exponent. So we'd start with the 5x to the third. Let's see if we can combine any like term. Excuse me, here I have a 7x and a 4x. They're both positive, so 7 plus 4, 11x, and then minus 1. And we've used everything up, so we're done. So this is a third degree. Leading coefficient of 5. Coefficient is just the number in front of the biggest, or in front of the x's. Number of terms, 3. So type, let's name it fully. I guess it's a cubic because it's to the third. And there's 3 terms, so it's a cubic trinomial. The last one, we probably should have named it a quadratic binomial because it had 2 terms. So let's talk about simplifying by adding. We can either add vertically or horizontally. If I add vertically, I would write them so they line up underneath each other. So the x squareds are with the x squareds and the x's are with the x's. So if you don't have one, we leave, like if we didn't have an x, we'd put 0x in so we can line them up beautifully. And then since we're adding, we just add 6 and 2, which is 8 x squareds. 3x minus 6x, so negative 3 or minus 3x. 7 minus 4 is plus 3. Adding horizontally, we don't need the parentheses, so I'm just going to write it all out. If you are adding it horizontally, I would suggest you box in things so you know what you've done. Like I will look for the x squared. So here's an x squared, and there's an x squared. And so then I would have 8x squared. And then I would pick a different shape. So I'm going to circle my x's. 3x, positive 3x, negative 6x, so minus 3x, and underline my variable, excuse me, my constants. So positive 7, negative 4 would be plus 3. So if you are adding horizontally, do something to show which terms you've used and which ones are alike. So adding, again, we'll do it, first we'll do it horizontally. So 2a squared plus ab plus 2b plus 4a squared minus 3ab plus 9. So let's see, a squareds, 2a squared, 4a squared. Altogether we have 6a squareds. AB's, we have plus AB and minus 3AB. So net gain of negative 2AB. And let's see, I have 2B, and I don't have anything to go with the 2B. And then I have the 9, plus 9. Now let's do this one horizontally, excuse me, vertically. So I would have 2a squared plus ab plus 2b. And then underneath it, I want to line things up. So I'm going to have 4a squared minus 3ab plus 0b's plus 9. So this would be plus 0 on top also. And now we're all lined up. 6a squared minus 2ab plus 2b plus 9. Oh, and I noticed up above I had a mistake. It was supposed to be 2b there. I don't know why I just put a b, but that should have been a 2b up above. So there's horizontally and vertically adding. Subtraction, you have to be careful. If we're subtracting 2x squared minus y squared from 5x squared from that trinomial. Let's do a1. But we have to be careful so we distribute the negative. So I am going to write, it said we're subtracting the binomial from the trinomial, so we take the trinomial first. And underneath it, I'm going to subtract, and I'm going to use parentheses because I need to distribute the subtraction. And I'm going to line things up. So I have 0 xy's, but I have y squared, so minus y squared. Now I'm going to, subtraction is the same as adding the opposite, so I'm going to change it to adding the opposite. Of course, it doesn't matter on the 0. But now I'm adding 5x squared and negative 2x squared, so that would be 3x squared plus 7xy plus 3y squareds. And the second way, I would have 5x squared plus 7xy plus 2. I'm going to see if I can move the whole thing down and move it over. Let's see. And from that, I want to subtract 2x squared minus y. So again, subtraction is the same as adding the opposite. Now I'm going to circle my similar terms. So 5x squared minus 2x squared is 3x squared. 7xy doesn't have anything to combine with, so 7xy. I see I wrote this. Boy, did I write this wrong. All right, let's look up above again. 5x squared plus 7xy plus 2y squared. And then the other one was 2x squared minus 2x squared minus y squared. So I went back and fixed it. Sorry that I totally messed up writing that. Again, though, I'm gathering like terms. So 5x squared minus 2x squared is 3x squared, 7xy all by itself. And now I can combine 2y squared and another y squared to give me 3y squared. So either way works. I like the vertical way to keep track of things because it's nice and neat. You can line them up beautifully. All right, let's try one more. I'm just going to do this one vertically. So 6x squared minus 2y plus 4 minus negative 3x squared plus 4y minus 3. And I'm going to change it to adding the opposite. Draw my line. 6x squared plus 3x squared, 9x squared. Negative 2y plus negative 4y is negative 6y. 4 plus 3 is 7. Plus 7. So if you were going to do it this way, I would change this to plus, adding the opposite, and then you would go and gather your like terms. That is it for this section.